Hello, everyone. My name is Ian Sebanja, and the talk of today is cost transparency and model return on investment. I am a product manager on the Intuit ML platform, and I have my colleague with me here, Srivatsan Kanchi, the engineering manager for the Intuit ML platform. We'll talk about the things we are doing to bubble up cost transparency at Intuit and how we help our stakeholders to determine return on investment. A bit of background about Intuit and what we do. Intuit is a software company that is focused on making financial software for consumers, small businesses, and those who are self-employed. Our three main products are TurboTax for tax filings, QuickBooks accounting software, and personal software Mint. Now, across all these products, we use machine learning to help enhance the customer experience. For example, in TurboTax, we use natural language processing models to suggest the right self-help articles. In QuickBooks, we use machine learning to forecast cash flow for businesses based on receipts, invoices, and other transactional data. In Mint, we use machine learning to categorize users' expenses so that we can help them to budget and they can see where their money is being spent. A few things to highlight with the Intuit ML platform. Cumulatively, we've had 400 plus models in production. We have 8,000 features. On the tech side, we are in AWS and leverage a lot of technologies there, such as SageMaker and Kubernetes. We use other open source tools such as Argo for orchestration. The title of this talk is Cost Transparency and Model Return on Investment. So let's start with the first part around cost transparency. This means you have cost. So why does cost matter? So as the ML platform, you're there, you have things running, you have your consumers, they're doing their AI ML work, it's represented by this black box. And at the same time, you have finance that is looking at costs and how they're adding up. Now, this is something that we have encountered on the ML platform. We see that some models are consuming resources and finance comes to us, hey, why are we being charged 10,000 for this model? Now, a little bit of context. At Intuit, the way the ML platform works is once we get any bills related to AI ML work, we pass on these bills to the different functional groups or BUs segmented out by the models that they are leveraging. So we get the bill and then we in turn charge back the BUs. That's why we had the account or finance folks from the BU coming to talk to us. Now, why cost matters? As I said, we are in AWS, and I assume that a lot of people here are also in the cloud. A majority of the AI ML workloads are going to be in the cloud. It could be AWS, GCP, Azure, take your pick. And according to a recent article from Anderson Horowitz, they say that cloud infrastructure has a significant cost, especially for AI and ML workloads. And the thing is, they say that this can be hidden. The key word is hidden. We want to be aware of what the costs are, and then later on, we can optimize on what are the right levers to pull. Now, on the ML platform, we want to be aware of how things are running. That is, we want to know which things are expensive, which things are cheap, where can we optimize. But when it comes to our customers, we can't bubble up this information. This is too much details for them. So the question is, how do we, on the one hand, make sure the costs are not hidden while not overburdening our customers? At Intuit, we've managed to strike the right balance. So a little bit of how ML is used at Intuit and how that has led to costs, but at the same time, the costs have not exploded. So we've seen a 15x increase in AI ML utilization at Intuit, while at the same time, the costs have not increased at the same pace. If they were, soon we'll be out of business. So we have been able to make sure that we have a control on how our costs are and where they're running. The rest of this talk will talk about what are the things that we have done to ensure this. So the way this is broken out, we have things that we have done on the technical side, and Srivasan will talk about approach. And the two main things we've done there is to focus on specific areas that have a higher return on investment as a platform, and also for the AI workloads that we are running. Then the other thing is we've made sure that we minimize the burden to the data scientists and ML engineers. That is, they do not have to start going into the nitty gritty of where do I optimize or going into the AWS console. On the non-technical side, we've had to make sure that we bubble up the costs. We are transparent with everything we do. We partner with our stakeholders to make sure that we are optimizing their workloads. And finally, eventually, making sure that we bubble up the ROI cost. So with that, I would like to ask my colleague Srivasan to start by talking on what we've done on the technical side of things. Srivasan?
Thank you, Ian. Thanks for the introduction, and hello to everyone. I want to talk about what the ML platform provides and how we enable cost controls and cost transparency. To give an overview on what the ML platform offers in terms of services, the Intuit ML platform provides end-to-end machine learning capabilities from ingestion of data, exploration, feature processing, storing set features in the feature store, model training, model evaluation, hosting models for inference, both online and in batch, and taking feedback from the models and creating a feedback loop that goes back into this ecosystem for retraining and other model activities. And this is where you will see some of the ROI conversation coming in as well. All of this is orchestrated using orchestration tools, model lifecycle management tools, and so on. For the purposes of this talk, we want to focus on the areas which have high cost impact. So we're not going to talk about ingestion and curation and the exploration parts, nor are we going to talk about the orchestration tools, which are horizontal, and this is more like a capital expenditure for the platform. We're going to focus on how we track cost across these phases of feature processing, feature store, model training and evaluation, inference, and performance evaluation. Feature extraction is an expensive process. However, features are also extremely useful for feature reuse across models, because the richer your feature sets, the better your models and the more ML models and more business benefit the ML models can provide. So there is a fine balance here when you're doing feature processing, because you want to make sure that your feature processing is effective. At the same time, it is also cost efficient. Similarly with training. Training typically has a large infrastructure footprint with many models needing GPUs and high compute that is pretty expensive on the cloud. Inference racks up the bills pretty quickly because you are serving hundreds of millions of requests 24/7, and these models need to be highly performant. So there is a huge cost for running our models 24/7 for inference. And in the batch use cases, the batch processing processes terabytes of data, and they need to be super efficient as well. Finally, the model performance and evaluation capabilities are extremely important, because this is what helps determine the ROI by providing that feedback. Let's talk about trade-offs. Cost always amounts to trade-offs that you are willing to sustain in the cloud world. For example, some trade-offs could be, do you want to have higher throughput or lower throughput? Or do you want to, are you okay? What kind of response times are you okay with for this use cases? And these decisions always have an impact on the cost that a model accrues and the company has to bear. One of the things that we want to do as the ML platform is to minimize the overload for our data scientists. Because we want to, as an ML platform, we want to provide data scientists with all the tools so that they can do their job, which is building great ML models and not worry about some of the nitty-gritties of how do I run this model efficiently in the cloud. Those are difficult decisions, and we want to take those away from the data scientist thought process. So what we do here in order to enable from a cost perspective is we allow for fine-grained tagging and tracking with resource isolation. Each model is isolated in its own sandbox by the platform, which is then tagged and tracked across the board. The tags that we employ will inform us about the user ID, system ID, project ID, financial unit IDs, and a host of other information. And all of this is automatically done for the model owners. And an example of this is here, where you can see that there is a bunch of tags, and this is a snapshot of the total number of tags that we have that allow for us to track what is the asset ID, what is the financial unit which is responsible for this model, and so on. We also segregate our model lifecycle into day one and day n. So day one is the first time a model comes into existence. We want to make that process dead simple. We want our data scientists to get started with building models with no overhead. So what we do for that is we have a notion of a project, and models are associated with the project. This allows us to collect a lot of the metadata around cost and around security and compliance once per project, and then leverage that for the models across the board. This also allows us to do resource isolation. As you can see here, this is a self-serve experience in which our data scientists come in and create a new ML model, and they're now able to select which business unit or financial party is responsible for this. How should this model be organized in our universe of ML models? Where does it fit in, and so on. Once a model gets created, it also gets this unique ID called an asset ID. Now, this asset ID is the connective tissue that holds the ML model's infrastructure together. And you can now track to a very fine-grained detail what is the infrastructure used by this particular model, whether it be with this asset ID, you can now track to a very fine-grained detail the infrastructure that is used by the model, whether it be storage used in the feature store, or whether it is compute used for training, feature engineering, and model inference. Now let's look at day n. It's very important for data scientists as they operate the ML models to be able to tweak different settings without overthinking them. So we provide a lot of easy controls. For example, how many machines do I want? Do I want them to be auto-scaled or fixed-scaled? How much is it going to cost me if I do this? So there is a immediate visibility and transparency in terms of the cost that a particular decision is going to accrue. And our data scientists can then make data-driven decisions based on the needs of the business at that time. Similarly, for training, we have a similar kind of easy controls where data scientists can come in and declare what is the resources that they need for a particular training run. The second important thing about day n is around automation of what? Automation to find out what are the right parameters that my model needs to run at so that it can give the best cost efficiencies. As we saw earlier, there were a couple of levers that we can pull around throughput and around response times and so on. This example we are showing an automation that exercises these parameters and exercises the model uh, on these parameters and gives an optimal result, which is the most cost efficient uh, way that this particular model can run. So, for example, and these are made up numbers, these are not real numbers. So let's say the expected TPS is 10 and the TP99 response time has to be 500 milliseconds. What should my cloud configuration be? And there is an automation that goes and runs through close to 40 to 50 different combinations of hardware configurations on the cloud and comes out with the result of, hey, if you want to achieve this kind of performance, this is the most optimal uh, configuration on the cloud. So the other thing is about default and having smart defaults. So smart defaults, uh, we look at the data across the number of models that we have, hundreds of models that are on the Intuit platform, and look at, hey, what are the most commonly used um, infrastructure parameters? Can we default them so that our data scientists do not have to think about what those have to be? And in the process, they may choose something that is inadvertently going to cost much more money. So uh, the platform enables smart defaults across the board. For example, in our SageMaker notebooks, we have a smart default of 3 hours before it automatically gets stopped. Why 3 hours? We looked at the data usage patterns of the notebooks and uh, found that 3 hours provides the right uh, balance between usability of the notebooks versus cost being accrued. Similarly, for online hosting, we have smart defaults, defaulted to instance count 1 and large instance size because that seems to work for most models as they start off. But the key thing here is all of these are controllable by our data scientists. So they start off with a smart default and then they build on top of that. They can either increase it to whatever they want or they can either decrease it to whatever they want. And a similar configuration exists for model training, where they specify in a declarative YAML file what is the instance counts that are needed. So with these, we are able to, with this technical approaches sprinkled across the platform, we are able to provide transparency and visibility for our data scientists into what costs are they going to accrue, what are the levers that they can pull in order to adjust these costs. Now I'll hand it over to Ian, who can talk about some of the other approaches that we have taken in order to uh, address cost control.
Yeah. Okay. Thank you, Srivatsan, for that. So I want to talk about some of the things that we have to do that are not related to the technical side. So I'll talk about the 3 points that are needed in order to make sure that this cost transparency and ROI is successful at any organization. So the things are around transparency and visibility, and also ensuring that the costs as you see them, the users can trust them. What does this specifically mean? It means that you want to provide the information at the right time within the right context so that the user knows, okay, because I ran this perf test with these parameters, this was the cost. Now, from there, I can tweak things. And as I tweak them, I can see how my costs are going to change. And I have agency to make certain decisions right there in the moment without having to go to some other console to change it, because you always want to provide information within context. Similar to what Srivatsan showed you earlier around showing the users that, hey, if you want to deploy on a fixed configuration, you can have this setting. But if you want to have an auto-scaled configuration, you can have this setting. And that allows them to make that determination that My model, it's okay with just a fixed configuration because the traffic pattern, I know it, or I want to use a auto-scaled setting. The main point here is once we've also talked about the feedback loop of the costs, at the same time, the scaling or no scaling is provided in context of the actions the user is doing so that they can make these decisions and uh, ensure that they're using the resources very well. However, this also goes hand in hand with another thing, which is partnerships and education. One of the things we have done is we've worked with our stakeholders to make sure that we are informing them and collaborating with them so that they can trust our results. What does this mean? It means that when we say the default is this, they trust the default because it's not something that is coming out of the blue. The information was provided in context and we have worked with them. The other thing is when we collaborate and we come up with tools, it enables us to make sure that there is a proper lineage of costs and that feedback loop. For example, we can show the cost, but it's up to the model owners to determine what is that feedback loop regarding the model performance and evaluation. So we've worked with Intuit AI, our partner organization, to make sure that we integrate the feedback loop into our system so that you can have that ROI. The other thing that we recently collaborated on was how do you run at scale AI workloads within Kubernetes? And one of the things we have done is we worked with them to define how can we optimize the Python model so that they work well and have lower cost footprint. Now, the outcome of this is that one, they'll trust the defaults that we present to them. They'll trust the costs that we show them because we have been working with them. It's not something that is coming out of the black box. So collaboration is very important in order to make sure that you have cost transparency and that ROI calculation, which then leads to my next point and my final point, which is determining ROI. So you've collaborated with the organization, you have visibility, you have everything in place. Remember, the key part that I talked about previously was making sure that you have the right information. If you've done everything I talked about previously well, the ROI conversation is very easy. One, the ML platform team is not going to determine the ROI, but having talked to the partner teams and having that trust, the users have this information to make that determination that, you know what, we've looked at this model and we have good ROI, or we need to improve these levels. And this is something that we have seen within our organization. That is, we deliberately do not make that ROI decision because different models have different ways of determining ROI. Some models lead to revenue generation, other models could lead to cost reduction, but other models also lead to better usability. Now, on the ML platform side, we can't make that decision, but we can empower our partners, our users of the platform to make that decision. And that's why having transparency, having that partnership is really important. So, what has this done for Intuit? Well, this um, this has helped us in that one, we have seen a almost linear growth in cost versus the exponential growth we've seen in leveraging AI at Intuit. That means as AI use has increased exponentially, our costs have not increased at the same pace. Secondly, as cost transparency has been bubbled up to the users, this has helped us as an organization to determine the impact of AI and ML at Intuit, and we are able to clearly show that it is beneficial. The third thing is through collaborating with our partners and users, we've had this general theme of skill up leveling. The slide I showed you around how to efficiently run Python on Kubernetes, that is something that now will take all users forward in the next use cases that they have, and in turn, that will reduce the overall cost for our ML workloads. Now, going back to my earlier point of, why am I being charged 10K for this model? Well, this is how we're able to resolve this, right? So we, as the platform team, were able to show our business partners that, hey, this is the model, this is the data scientist responsible, and that collaboration between finance and the data scientist and the transparency we had, they were able to make that determination that, okay, you know what? This is how we are going to take this model forward. We are going to deploy it. And that is just one of the many outcomes that could have come out. The other thing could have been, how do we optimize this model so that we reduce the cost? The other part could have been, how do we invest in another area or a slightly cheaper model? The main goal is we do not make the decision, but we provide data that helps to drive the decision-making process for our partners. I hope this is useful, and we are happy to take any questions. Thanks for your time.
All right. Thanks so much, Ian and Shrivatsan. So many questions. I think we could do a whole presentation just on that one slide, best practices for Python on Kubernetes.
Yeah.
Just out of the gate, one of my questions is, at the very end, you kind of talked about the impact of this, and you're able to have this kind of after action review. But I'm wondering the extent to which this changes the culture even before, earlier in the process. Do you see data scientists spending a lot of time kind of tweaking model parameters or other aspects of the way they build these models, kind of being conscious of cost?
So we have seen that, yes, it has changed the way that data science is done, because from the beginning, it starts from how is this going to impact the business, and knowing that impact, then as they are working on the model, they are cognizant of the costs. At the same time, it's an optional. You don't start from that. You can always optimize later because the information is provided. So first pass, let's put it out there, and then we can start optimizing.
Great. I'll mention to folks that if you haven't been following the chat, there have been a ton of questions answered in the chat. Click on the session tab to get access to the chat if you don't already have it. Alan's wondering if there's an even bigger kind of net impact of this. Do you look at the aggregate model costs and say, maybe the cloud isn't the way to do this. We could do it by rolling our own.
Yeah. So I'll let's reverse and take a stab later. But I part of being in the cloud is there is the cost aspect, but the most important thing is the flexibility and the speed it allows you to operate at, because data science and the industry we are in, technology, it moves very fast. If you have on-prem, I think you're handicapping yourself in terms of speed and delivery.
Shrivatsan?
Totally agree on that. And Intuit as a company has taken a stance that we are going to be in the cloud. So we do not have an option of an on-prem. We sold our last data center last year, I think. So we have to figure out how to make the best and how to make ML really cost efficient on AWS and on the cloud. And so we use a variety of techniques, and like the Python example that was shared, that was running on Kubernetes on AWS, and we were able to actually bring down costs significantly by applying some optimizations over there.
Awesome. Well, thanks so much, guys, for a great presentation and for being so active in the chat, getting those questions answered.